All right, let's dive into the world of AWS AI. Today we're using two guides, AWS AI Practitioner Exam Simplified Guide and AWS AI Practitioner Exam Study Notes, March 2025. And both sources really push this idea that AWS is making AI accessible to everyone. They use that Lego brick analogy.
Right.
Like AWS gives you the building blocks, and
Yeah.
even if you're not like a coding expert, you can build incredible AI solutions. So, what are some of the areas we'll be exploring in this deep dive?
Well, today we're going to explore a few key areas. We'll see how you can build custom AI with Amazon SageMaker and how you can use pre-built AI services for specific tasks. We'll even touch upon generative AI and foundation models, which are changing the way we think about AI creativity. Of course, we'll cover the practical side too, how to actually use these AI models and some important considerations to make sure your AI solutions are effective and efficient.
Okay, so let's start with this Amazon SageMaker thing. It sounds a little complex.
It might sound intimidating, but think of SageMaker as your personal AI workshop in the cloud. The great thing is it handles all the complicated stuff like the infrastructure setup and management. Imagine having a dedicated team taking care of all the servers and storage and all the networking so you can focus on building your AI models. The fun part.
So I don't need to be a server expert to use it.
Not at all. It's designed to be accessible, really, to developers, data scientists of all skill levels. And our sources point out some interesting tools within SageMaker, which makes it even easier. For example, there's SageMaker Jumpstart, which is like having a box of pre-built Lego kits, but for AI.
Oh, okay.
You can choose from a library of pre-trained models, algorithms for various tasks, and deploy them with just a few clicks. Great way to get a feel for AI or to jumpstart your project, if you need a solution quickly.
Okay, that sounds helpful, but what if I want to build something a little more custom, something unique to my needs?
SageMaker has you covered there as well. It provides all the tools you need to build, train, and deploy your own custom models. And for those who prefer a more visual approach, there's SageMaker Canvas, a no-code environment where you can build AI models using a drag-and-drop interface, much like building with visual Lego blocks, actually. Connect your data, select a model type, train the model, and get predictions, all without writing a single line of code.
That sounds incredible. How do I know if my models are actually doing a good job? Like, how do I track their performance, make sure they're working as I intended?
Well, SageMaker provides a tool called SageMaker Model Dashboard. It's like your central command center for monitoring your AI models. You can track various metrics, accuracy, latency, throughput, Get a clear picture of how your models are performing. This helps you to spot potential issues early on and to troubleshoot problems or retrain your models if necessary. Plus, SageMaker has tools for automating tasks like model deployment, scaling, and even A/B testing to keep your models running smoothly.
It really sounds like SageMaker handles a lot of the heavy lifting for you. Is there anything this thing can't do?
Well, it can't make you coffee, but it can definitely accelerate your AI projects. Another interesting feature that our sources highlight is SageMaker Deep Racer, a fun way to learn about reinforcement learning by actually racing virtual cars. You can train your own AI model to drive the car autonomously. You can compete against other racers, seeing your AI skills come to life on the track.
Okay, I'm sold. SageMaker sounds pretty awesome. But what about those times where I don't want to build a whole model from scratch? What if I just need a quick AI solution for a specific task?
Well, that's where pre-built AI services come in. Think of these as pre-assembled Lego sets that are ready to use right out of the box. AWS offers a huge range of these services, each designed to address a specific need.
So it's like choosing the right tool for the job rather than building every tool myself.
Precisely. One example is Amazon Kendra, like a supercharged search engine for your company's data. Imagine being able to ask, natural language questions about your internal documents, your reports, your chat logs even, and get precise answers within seconds.
That would be incredible. We have so much data scattered across all these different systems, and just finding the right information can feel like searching for a needle in a haystack.
Exactly. Kendra can help you to sift through that haystack and get the insights you need quickly and efficiently. Another example is Amazon Personalize. It's all about creating those Netflix-style recommendations, but for your business. It uses machine learning to understand your customers' preferences and then suggest products, content, offers tailored to their individual needs and interests.
That's pretty clever, like having a personal shopper for every customer. What other pre-built services are out there?
Well, there's Amazon Rekognition, which can analyze images and videos to identify objects, faces, scenes, and even emotions. Imagine being able to automatically tag photos, moderate content, even create personalized shopping experiences based on what people are wearing in videos. That's the power of recognition.
It's incredible. AI that can actually like see and understand visual content. That opens up so many possibilities. What about services for working with text and language?
Well, for those, Amazon Transcribe and Amazon Polly are your go-to services. Transcribe can convert speech to text with remarkable accuracy, which is great for transcribing meetings, creating subtitles, or analyzing customer service calls.
Mm.
And Polly can convert text to lifelike speech in multiple languages, which is great for creating audiobooks, voiceovers for videos, or even building interactive voice response systems.
So I could have Polly read me a bedtime story.
Absolutely. Polly can make even the most technical documentation sound engaging. And lastly, let's not forget about Amazon Forecast. As the name suggests, it's all about predicting the future. It uses machine learning to analyze historical time series data and generate forecasts for things like sales, demand, inventory, even website traffic.
Wow, predicting the future. That's a powerful tool for any business. I'm starting to see how these pre-built services can be incredibly useful for solving specific problems.
They offer a very quick and easy way to integrate AI capabilities into your applications and workflows without the need for deep machine learning expertise. What's even better is that they're constantly being updated and improved, with new features and capabilities.
Okay, this is all really impressive. We've covered SageMaker for building custom AI. We've explored these pre-built AI services. What else is there in this AWS AI universe?
Well, let's talk about the exciting round of generative AI, a field where AI isn't just analyzing data, but creating new content. This is where things get really interesting.
Generative AI, it sounds futuristic. What exactly does it do?
Well, generative AI uses complex algorithms to generate new content. Things like text, images, music, even code. Think of it as AI that can write stories, compose songs, design websites. It's a very rapidly evolving field, and there are a couple of key concepts to understand.
Okay, lay it on me. I'm ready for the future.
The first concept is foundation models. These are large, powerful AI models that are trained on massive amounts of data, often encompassing text, images, code, and more. Think of them as super smart AI brains that have a broad understanding of the world. They can be used for a wide range of tasks, from generating different creative text formats like poems, codes, scripts, musical pieces, email, letters, etc., even to answering your questions in an informative way, even if they're open-ended, challenging, or strange.
Wow, they sound almost human. So what's the difference between a foundation model and a large language model?
Well, large language models, or LLMs, are a specific type of foundation model. They focus on understanding and generating text and language, like the language specialists, within the world of foundation models. They're trained on just vast amounts of text data and can perform tasks like translation, summarization, question answering, and even creative writing. They're actually what power those chatbots and AI assistants that you interact with online.
So it's like a foundation model is the generalist, and the large language model is the expert in all things language.
Yep.
Makes sense. How can we actually use these foundation models and LLMs?
Well, that's where Amazon Bedrock comes in. It's a service that gives you access to a variety of foundation models from different providers, including Amazon's own models and models from companies like AI21 Labs, Anthropic, and Stability AI. This gives you a lot of flexibility to choose the model that best suits your needs, to experiment with different models for different tasks.
So it's like a buffet of AI brains. And I can pick and choose the ones that work best for my project. But can you really tailor these models to your specific needs?
Absolutely. A key aspect of working with foundation models is fine-tuning. You can take a pre-trained foundation model and further train it on a smaller, more specific data set that's relevant to your particular task.
So it's like giving the model like extra training in a specific area so it becomes even more specialized. I'm guessing this is particularly helpful for LLMs to make them better at, say, understanding legal documents or medical records.
Exactly. You can fine-tune an LLM to become an expert in a particular domain. For example, if you're building a chatbot for a healthcare company, you can fine-tune an LLM on medical text and conversations so it can understand, medical terminology and answer patient questions accurately.
Okay, that makes sense. We've talked about building custom AI with SageMaker, using pre-built AI services for specific tasks, and now we've delved into the world of generative AI and foundation models. This has been a lot to take in, but it's all so fascinating.
It's a lot to cover, and we've really only just scratched the surface. But it's clear that AI is becoming more powerful and accessible every day. And AWS is at the forefront of making these tools available to everyone.
Before we move on to the next section, I'm curious, we've built all these incredible models. How do we actually use them in the real world? How do we go from having a trained model to actually getting predictions or insights from it?
That's a great question, and it brings us to the concept of inference. Inference is essentially the process of using a trained AI model to make predictions or decisions on new data.
So it's like asking our trained AI a question and getting an answer based on what it's learned, but I'm guessing there's more to it than just like asking a question.
You're right. The way you ask the question and the kind of answer you need will determine which inference type is best for you. There are three main types of inference:
Hmm.
real-time inference, asynchronous inference, and batch inference.
Okay, break it down for me. What are the differences between these inference types?
Well, let's start with real-time inference. This is when you need an instant response from your AI model. Think of it like having a conversation with a chatbot. You ask a question, you expect an immediate reply. This type of inference is often used for applications like fraud detection, where decisions need to be made in real time, or for interactive voice assistants, where users expect, instant feedback.
So real-time inference is all about speed and immediacy. What about asynchronous inference?
Asynchronous inference is more like sending an email and waiting for a reply. You send your request to the AI model, it processes it in the background, sending you the results later. This type of inference is suitable for tasks that don't require an immediate response. Things like image processing, document analysis, or generating personalized recommendations overnight.
So it's more about efficiency than speed. What about batch inference?
Batch inference is when you have a large amount of data that you want to process all at once. It's like sending a bulk email to a large group of people. Instead of processing each request individually, you send a batch of requests to the model, and it processes them all together, delivering the results, as a batch.
So batch inference is like a bulk processing option for AI. That makes sense. When choosing between these inference types, are there any trade-offs to consider?
Oh, there are definitely trade-offs to consider. Real-time inference is fantastic for speed, but it can be more expensive because you need to keep the model running and ready to respond instantly. Asynchronous inference is more cost-effective, but you have to be okay with some delay in getting the results. Batch inference is the most efficient for large data sets, but it might not be suitable for tasks that require, real-time responses.
Okay, so choosing the right inference type depends on the specific needs of my application. What else do we need to know about using these AI models in real-world scenarios?
Well, one of the most important things to remember is that AI models are not perfect. They can make mistakes, and they can be biased, especially if they're trained on biased data.
That's a really good point. AI is a powerful tool, but it's really important to use it responsibly and to be aware of its limitations.
Exactly. We'll delve deeper into those ethical considerations later on. But for now, let's continue exploring the practical side of things.
Sounds good to me. Let's dive in. So we've got these super powerful AI models and different ways to use them. It's like having a high-tech toolbox. But aren't there times when even the smartest AI needs a little help from us humans?
You're absolutely right. AI has come a long way, but there's still certain tasks where humans really excel. Particularly those requiring nuanced judgment, creativity, or a deep understanding of context.
So it's not just about replacing humans with AI, it's more about finding that right balance, a collaboration between human intelligence and artificial intelligence.
Precisely. And AWS actually provides a really interesting tool that facilitates this collaboration: Amazon Mechanical Turk, MTurk for short.
MTurk. That name always makes me think of some kind of like futuristic robotic workforce. What is it exactly?
It's not quite a robotic workforce, but it is pretty ingenious. Think of MTurk as a global marketplace. You can connect with a vast pool of human workers to perform tasks that are difficult for computers, but relatively easy for humans.
Okay, so what kind of tasks are we talking about here? Give me some examples.
Okay, so imagine you're training an image recognition model to identify different types of flowers. You need a huge data set of labeled images, meaning images where someone has clearly identified the type of flower in each picture.
Right, and labeling thousands of images would be so tedious and time-consuming for a human, but it's something that humans can still do much more accurately than AI systems, I think.
Exactly, that's where MTurk comes in. You create a task on MTurk, provide instructions and examples, and then have a large number of workers label those images for you.
So it's like crowdsourcing data labeling, harnessing the power of human intelligence to improve AI models.
Precisely. And it's not just limited to image labeling. MTurk can be used for a wide range of tasks like transcribing audio, moderating content, conducting surveys, and even gathering opinions and feedback on product designs.
That human-in-the-loop approach seems incredibly valuable. But what about ensuring the quality of work done on MTurk?
Well, MTurk has mechanisms in place to address that concern. You can set quality control measures, such as having multiple workers complete the same task and then comparing their results. You can also provide, very clear instructions and examples to guide those workers, and even offer bonuses for high-quality work.
So it's like having a quality assurance process built right into the platform. That's reassuring. We've talked about SageMaker, pre-built AI services, generative AI, and even the human element with MTurk. Is there anything else we need to cover in terms of this big picture of AI on AWS?
Well, we've covered the core components, but there's a couple essential aspects we need to touch upon. First, let's talk about machine learning itself.
Okay, machine learning, the engine behind all this AI magic. I have to admit it can sound a bit intimidating. Do I need to be a math whiz to understand it?
Not at all. You don't need a PhD in mathematics to grasp the fundamental concepts of machine learning. It's more about understanding the different ways that machines can learn from data. There are three basic types of machine learning: supervised learning, unsupervised learning, and reinforcement learning.
Okay. Three types of machine learning. Let's start with supervised learning. What's that all about?
Think of supervised learning as learning with a teacher. You give the machine a set of labeled examples, which means you provide both the input data and the desired output. For example, let's say you were training a model to distinguish between pictures of cats and dogs. You would provide it with images that are clearly labeled as either cat or dog.
So the machine learns from these labeled examples to figure out the patterns that distinguish cats from dogs.
Exactly. And once it's learned those patterns, it can then use them to classify new images it's never seen before.
That makes sense. What about unsupervised learning? Is it like learning without a teacher?
You got it. In unsupervised learning, you don't provide the machine with those labeled examples. Instead, you just give it a data set and let it figure out the patterns and relationships all on its own. It's like giving a machine a puzzle to solve, but without giving it the picture on the box.
Okay, so the machine has to find its own way, discovering the hidden structure within the data. That sounds pretty challenging. What kinds of tasks does unsupervised learning excel at?
Well, unsupervised learning is great for tasks like clustering, where you want to group similar items together, or for anomaly detection, where you want to identify data points that are different from the norm. It's also used for dimensionality reduction, which is a way of simplifying complex data by, reducing the number of variables while preserving the most important information.
Okay, I'm starting to see how these different types of machine learning can be applied to different problems. What about reinforcement learning? It sounds kind of intense.
Reinforcement learning is kind of like teaching a dog a new trick. You reward the dog when it performs the trick correctly, and you might correct it or withhold the reward when it makes a mistake. Over time, the dog learns to associate certain actions with positive outcomes and others with negative outcomes, and it starts to make better decisions.
So in reinforcement learning, the machine is like the dog, learning through trial and error, trying different actions and adjusting its behavior based on the feedback it receives.
Exactly. And instead of treats, the rewards in reinforcement learning might be things like points at a game or reaching a specific goal in a simulation.
I can see how reinforcement learning could be really powerful for things like training robots or developing self-driving cars.
Absolutely. It's a very powerful technique. It's being used for a wide range of applications, from optimizing traffic flow in cities to controlling energy consumption in buildings.
Okay, we've covered the three main types of machine learning. What else do we need to know to really understand how this all works, how AI works?
Well, one crucial aspect is understanding how data is prepared for machine learning. It's not just about feeding raw data into a model and hoping for the best. There's a process called feature engineering that is super crucial for getting the most out of your data.
Feature engineering sounds like we're building something.
In a way, we are. Features are the specific pieces of information that your model uses to make predictions or decisions. Think of them like the ingredients in a recipe. If you use the wrong ingredients or don't prepare them properly, well, your dish won't turn out as expected.
Okay, so feature engineering is about selecting the right data points and transforming them into a format that the model can understand and learn from.
Exactly. It's like prepping your data to be the perfect input for your machine learning model. And there are various techniques involved, like handling missing data, scaling numerical features, and encoding categorical features.
Can you explain those techniques a little more?
Sure. Let's start with handling missing data. Real-world data sets often have gaps or missing values, you need to decide how to deal with those gaps. You could remove rows with missing data, you could fill in the gaps with, average values, or use more sophisticated methods to estimate the missing values.
So it's about making sure your data set is complete and consistent. What about scaling numerical features?
Scaling numerical features is about ensuring that all your numerical features are on a similar scale. This is really important because some machine learning algorithms can be sensitive to the range of values in different features.
So if one feature has values ranging from 1 to 10, and another has values from 100 to 1,000, you want to scale them so they're both on a similar range.
Right. This prevents one feature from dominating the model and skewing the results. And then there's encoding categorical features.
Categorical features, those are the ones that represent categories or groups like colors, countries, or product types. How do you encode those?
You need to convert those text-based categories into numerical representations that the model can understand. There are various techniques for doing this, like one-hot encoding or label encoding.
So feature engineering is this crucial step in preparing data for machine learning. And AWS offers some tools to help with this, right?
Absolutely. SageMaker provides a service called SageMaker Feature Store, which helps you to organize, manage, and reuse features across different machine learning projects. It's like a centralized repository for your engineered features. It makes it much easier to collaborate and ensure consistency in your data preparation process.
Okay, so we've talked about machine learning types and feature engineering. What about managing all these different models we're creating? It seems like things could get pretty disorganized, especially if you're working on multiple projects with various models and data sets.
That's a very valid concern.
Yeah.
And it highlights the importance of model management. It's like having a well-organized workshop where all your tools and materials are, properly labeled and stored.
So model management is about keeping track of our models, their different versions, and their performance metrics, so we don't lose track of what's working and what needs improvement.
Exactly. And AWS provides a service called SageMaker Model Registry. It acts as a central repository for all your models. You can register your models, version them, store metadata about them, even control who has access to them.
So it's like a librarian for AI models, keeping everything organized and accessible. What are some of the key benefits of using a model registry?
Well, a model registry really helps you to track the lineage of your models, meaning you can see which data was used to train each model, how it evolved over time. This is crucial for reproducibility and for understanding how your models were created.
Okay, so it provides transparency and accountability. What else?
It also streamlines model deployment. Once you've registered a model, you can very easily deploy it to different environments, whether it's for testing, staging, or production.
So it simplifies the process of getting your models out into the real world. And of course, security is really paramount when dealing with valuable AI models and sensitive data.
Absolutely. Security in AI and machine learning is a top priority. We need to protect our data, models, and infrastructure from various threats, really.
So where do we even begin with AI security? It just seems like such a vast and complex landscape.
It is complex, but AWS offers a really layered approach to security, addressing multiple areas. Let's break it down into three key areas: data security, model security, and infrastructure security.
Okay, that sounds like a good framework. Let's start with data security. What are some of the best practices for protecting our data?
Well, first and foremost, encryption is absolutely crucial. We need to encrypt our data both at rest, when it's stored in databases or cloud storage, and in transit, when it's moving between systems. AWS Key Management Service, or KMS, provides a really robust way to manage encryption keys and protect our data.
So encryption is like putting our data in a locked safe. And KMS is the key master, making sure only authorized users have the keys. What else is important for data security?
Access control is absolutely vital. We need to control who has access to our data and at what level. AWS Identity and Access Management, or IAM, allows us to create granular permissions, ensuring that only authorized users can access, sensitive data.
Right. We don't want just anyone having access to our valuable data and models. Are there any other data security measures we should consider?
Well, data masking and anonymization are also really important techniques, especially when dealing with personally identifiable information. We can mask or redact sensitive data elements, making it harder to identify individuals while still preserving the data's usefulness for analysis and model training.
Okay, so we've covered data security. What about model security? How do we protect our trained AI models from, attacks or misuse?
Model security focuses on protecting the integrity and confidentiality of our models. We need to control access to those models. validate inputs to prevent malicious attacks, and monitor for any anomalies that could indicate tampering or compromise.
So it's like having a security system for our models, making sure only authorized users can access them and that they're not being manipulated or corrupted.
Exactly. And then we have infrastructure security, which is about securing the underlying systems and environments where our AI workloads run. This includes securing our SageMaker notebooks and endpoints, protecting our networks, and ensuring compliance with the relevant security standards.
So it's like building a secure fortress around our entire AI operation. What are some specific measures we can take to enhance infrastructure security?
Well, using virtual private clouds, or VPCs, is a great way to isolate our AI resources from the public internet. And to control network traffic, we can use security groups and network access control lists to define rules for, who can access our systems and what ports and protocols are allowed.
So it's like having a security checkpoint at the entrance to our AI fortress. What about monitoring and logging? They seem like pretty essential components of any security strategy.
Absolutely. We need to enable logging for all of our AI components to record events, user actions, and any suspicious activity. This provides an audit trail that can be invaluable for detecting security incidents and investigating, breaches.
And monitoring helps us see what's happening in real time so we can spot those potential issues before they turn into major problems.
Exactly. Tools like Amazon CloudWatch can monitor various metrics and alert us to any anomalies, performance degradation, or suspicious patterns that could indicate a security breach.
Okay, so we've covered a lot of ground on security. It's a complex and multifaceted topic, but it's clear that AWS provides a really robust set of tools and services to help us protect our AI assets. Now, before we move on, I want to address something that's always on the minds of businesses: cost. Cloud services can be fantastic, but they can also get expensive if you're not careful.
You are absolutely right. Cost optimization is essential, especially when dealing with, compute-intensive workloads like AI and machine learning.
So, how do we keep our AI ambitions from breaking the bank? What are some strategies for optimizing costs without sacrificing performance?
Well, there are a number of strategies we can employ. One key strategy is right-sizing instances, meaning choosing the most appropriate instance types for our training and inference workloads.
Okay, so it's about making sure we're not overspending on powerful instances when less expensive options would suffice.
Exactly. And for training jobs that can handle interruptions, spot instances can offer significant cost savings. Spot instances are spare compute capacity that AWS offers at a discounted price. The catch is they can be interrupted with short notice if AWS needs to reclaim that capacity.
So it's like getting a great deal on a flight, but you might have to be flexible with your travel plans.
A good analogy. And if our workload allows for it, serverless inference can be a very cost-effective option. With serverless inference, we don't have to manage any servers ourselves. AWS takes care of everything. And we only pay for the compute time we actually use.
So it's like renting a car only when you need it, rather than owning one and paying for it even when it's sitting in your garage. What other cost optimization strategies should we consider?
Auto-scaling can help us optimize costs by automatically adjusting the number of instances based on demand. If traffic spikes, the system will automatically scale up to handle the load, and when traffic subsides, it will scale down to save resources.
So it's like having an elastic workforce that expands and contracts based on the workload. Any other tips for keeping costs under control?
Regularly cleaning up unused resources is absolutely essential. Delete any idle instances, unused storage volumes, or, forgotten data sets. It's like decluttering your workspace to avoid unnecessary clutter and expenses.
Those are some great tips for optimizing costs. It sounds like there's a lot to consider when managing AI workloads on AWS, from security to costs and everything in between.
It is a lot to manage.
Mhm.
But AWS provides a really comprehensive set of tools and services to help us navigate these complexities and get the most out of our AI investments.
Mhm.
And one of the most crucial aspects of managing AI workloads is ensuring that our models continue to perform well after they've been deployed.
Right. It's not enough to just build and deploy a model. We need to make sure it's still doing its job effectively in the real world.
Exactly. And that brings us to the topic of model monitoring.
Okay, model monitoring. It sounds like we're keeping a watchful eye on our AI models, making sure they're behaving themselves.
You could say that. Model monitoring is about tracking the performance of our deployed models over time, detecting any potential issues early on, and taking corrective actions to ensure that our models remain accurate, reliable, and relevant.
So what kinds of issues might we encounter with deployed models? Why do they need this constant monitoring?
Well, one of the biggest challenges is something called model drift. Model drift happens when the performance of a model degrades over time because the data it's seeing in the real world starts to differ from the data it was trained on.
Okay, so it's like the model's knowledge is becoming outdated because the world is changing.
That's a good way to put it. The patterns and relationships that the model learned during training might no longer hold true, leading to inaccurate predictions or decisions.
So how do we detect this model drift? What are like the warning signs?
Well, we need to monitor various metrics, things like accuracy, precision, recall, and F1 score, to see if the model's performance is declining.
So we're looking for any significant drop in performance that might indicate the model is starting to struggle with the real-world data. What else should we be monitoring?
We should also monitor for data drift, which means changes in the distribution or characteristics of the input data. For instance, if we trained a model to predict customer churn based on certain demographic factors, and those demographic patterns change over time, well, the model might start making inaccurate predictions.
So we need to make sure the data the model is seeing in production is still consistent with the data it was trained on. What about changes in the relationships between the data and the target variable?
That's called concept drift, and it's a bit trickier to detect. Concept drift happens when the underlying relationships between the input features and the target variable change over time.
So even if the data itself doesn't change that dramatically, the way it influences the outcome might change. How do we detect concept drift?
Well, concept drift is often inferred from performance degradation, especially if we've ruled out other factors like data drift or bugs in our code. If the model's performance is declining but the input data seems consistent, well, it could be a sign of concept drift.
Okay, so we need to be on the lookout for model drift, data drift, and concept drift. It sounds like a lot to keep track of.
It is, but AWS provides tools to help us with this. SageMaker Model Monitor is a service that allows us to set up monitors for various metrics, and it will automatically alert us if it detects any anomalies or issues that could indicate drift or other problems.
So it's like having a watchdog for our models, keeping a close eye on their performance and alerting us if anything seems amiss.
Exactly. And SageMaker Model Dashboard provides a really nice visual overview of our model's performance and health, making it much easier to spot trends and potential issues.
Okay, so we've covered a lot of ground in this deep dive. We've explored SageMaker for building custom AI. We've looked at pre-built AI services for specific tasks. We've delved into generative AI and foundation models. We've discussed the human-in-the-loop approach with MTurk. We've explored the different types of machine learning and the importance of feature engineering. We've talked about model management and security. We've addressed cost optimization strategies. And now we've covered model monitoring. Phew.
We have certainly covered a lot. And there is still so much more to explore in the world of AWS AI.
It's clear that AWS offers a really comprehensive and powerful platform for building, deploying, and managing AI solutions.
Absolutely. And as AI continues to evolve and become more integrated into our lives, having a really solid understanding of these tools and concepts will be essential for, anyone working with data, building applications, or simply trying to understand the forces shaping our world.
Before we wrap things up, I'm curious, now that we've taken this deep dive into AWS AI, is there a way to summarize the entire journey? It's like we've been on this epic adventure, and I want to make sure I have a map to guide me through it all.
That's a great analogy. And yes, we can think of the AML lifecycle on AWS as a roadmap. It guides us through the various stages of building, deploying, and managing AI solutions.
Okay, let's unroll that roadmap and see what we've got.
The AML lifecycle on AWS typically involves 5 main stages, starting with data ingestion and preparation. This is where we gather our raw data from various sources, like databases, applications, or even IoT devices.
Right, we need to get all our ingredients together before we can start cooking up our AI magic.
Exactly. And once we have our data, we need to prepare it for machine learning. This involves cleaning the data, handling those missing values, transforming it into a suitable format, and engineering those valuable features that we talked about earlier.
So it's all about making sure our data is clean, consistent, and ready to be fed into our machine learning models.
Right. Once our data is prepped, we move on to model development and training. This is where we choose the appropriate machine learning algorithm for our task, whether it's supervised, unsupervised, or reinforcement learning. And then we train our model on the prepared data using, those powerful computing resources provided by AWS.
So it's like setting up our training ground and putting our model through its paces.
A very good analogy. And this training process often involves experimenting with different model architectures, tuning hyperparameters to optimize performance, and analyzing the model's behavior to identify any potential issues.
Sounds like a lot of experimentation and fine-tuning to get the model just right. What happens after we've trained our model?
The next stage is model evaluation and validation. This is where we assess how well our model performs on unseen data, making sure it generalizes well and isn't just memorizing the training data.
Right. We want to make sure our model can handle real-world data, not just those specific examples it was trained on.
Exactly. And we also need to validate that our model is making, fair and ethical decisions, especially if it's being used in sensitive domains like healthcare or finance.
Okay, so model evaluation and validation are all about making sure our model is accurate, reliable, and ethical. What happens once we've given our model the green light?
Then we move on to model deployment, which means getting our model ready to be used in real-world applications. We register our model in SageMaker Model Registry to keep track of it, and then we deploy it to an endpoint where it can receive requests and generate predictions.
So it's like setting up shop for our model, making it accessible to users or other systems.
A good way to think about it. And finally, we have model monitoring and management, which is an ongoing process. We need to continuously monitor our model's performance, detect any drift or degradation, and take corrective actions to ensure it remains effective over time.
So it's not just a one-and-done process, it's this continuous cycle of improvement and adaptation.
Precisely. And AWS provides a wealth of tools and services to support us throughout this entire life cycle, from data preparation and model training to deployment, monitoring, and management.
Okay. That was a great overview of that AML lifecycle on AWS. It's like having a roadmap for success in the world of AI.
Exactly. And as AI continues to evolve at such a rapid pace, understanding this life cycle will be crucial for individuals and organizations alike.
This deep dive has been incredibly informative, but it's also sparked a lot of new questions and ideas in my mind.
That's the beauty of exploring a field like AI. It constantly pushes the boundaries of what's possible and opens up new avenues for innovation and discovery.
Before we wrap things up completely, I want to touch on one more thing. We've talked a lot about the technical aspects of AI on AWS, but I'm also curious about the human side of things.
That's an important point. AI isn't just about algorithms and data. It's ultimately about people. It's about how we use these tools to solve problems, improve lives, and create a better future.
Exactly. So let's take a step back and think about the bigger picture of AI and its impact on society. What are some of the key considerations we need to keep in mind as we embrace this powerful technology?
Well, one of the most important considerations is responsibility. We need to develop and deploy AI systems in a responsible and ethical manner, ensuring that they are used for good, not for harm.
Right. We don't want to create AI that perpetuates biases, discriminates against certain groups, or violates people's privacy.
Absolutely. We need to be very mindful of the potential consequences of our actions and ensure that our AI systems are really aligned with human values.
So it's not just about building cool technology, it's about building technology that benefits humanity.
Precisely. And that requires careful consideration of ethical implications, social impact, and the potential risks and benefits of AI.
Another important aspect is the impact on the workforce. AI is automating tasks that were previously done by humans, and this is raising concerns about, job displacement.
That's a very valid concern. It's important to remember that AI is a tool, and like any tool, it can be used for good or for ill. We need to find ways to harness the power of AI while also creating new opportunities for human workers.
So it's not just about replacing jobs with AI, it's about reimagining the nature of work and finding ways for humans and AI to collaborate effectively.
Exactly. We need to invest in education and training to equip workers with the skills they need to thrive in an AI-driven world.
Okay, so responsibility, ethics, and workforce impact are all crucial considerations as we navigate this AI revolution. What else should we be thinking about?
We also need to think about accessibility and inclusivity. AI should be accessible to everyone, regardless of their technical background, resources, or location.
Right. We don't want to create an AI elite where only a select few have access to these powerful tools.
Exactly. We need to democratize AI and make sure its benefits are widely shared.
This deep dive has been so eye-opening. It's clear that AI is this powerful force that's transforming our world, and it's so crucial that we use it wisely and responsibly.
I completely agree. The future of AI is really in our hands, and it's up to us to shape it in a way that benefits all of humanity.
This has been an incredible journey, and I feel like I've gained a much deeper understanding of the world of AWS AI.
I'm glad to hear that. And remember, this is just the beginning. The field of AI is constantly evolving, and there's always more to learn and explore.
I'm definitely feeling inspired to continue exploring this fascinating world. What are some resources or next steps you would recommend for someone who wants to delve deeper into AWS AI?
Well, AWS offers a wealth of resources for learning about AI and machine learning. They have excellent documentation, tutorials, and online courses that cater to various skill levels.
That's great to know. I'm also curious, are there any specific AWS services or tools that you would recommend exploring further?
SageMaker is a great starting point. It's a very comprehensive platform for building, training, and deploying those machine learning models.
Right. We've covered SageMaker extensively in this deep dive, and it's clear that it's a really powerful and versatile tool. What about those pre-built AI services we talked about earlier?
Those are definitely worth exploring. They offer a quick and easy way to integrate AI capabilities into your applications, without having to build complex models from scratch.
And for those who are interested in the cutting edge of AI, generative AI and foundation models are fascinating areas to dive into.
Absolutely. Amazon Bedrock provides access to a variety of foundation models, making it easier to experiment with and leverage these powerful AI systems.
Okay, so there's no shortage of resources and tools for anyone who wants to explore the world of AWS AI.
Exactly. And the best way to learn is by doing. Start experimenting, build some projects, and don't be afraid to ask questions and seek guidance from that AWS community.
That's great advice. I'm feeling inspired to dive in and start building something amazing.
That's the spirit. The possibilities are truly endless.
Before we sign off, I want to thank you for sharing your expertise and insights with us today. It's been an incredible journey.
It's been my pleasure. And remember, the world of AI is constantly evolving, so keep learning, keep experimenting, and keep pushing the boundaries of what's possible.
That's a great note to end on. So to all our listeners, thank you for joining us on this deep dive into AWS AI. We hope you've gained valuable insights and inspiration to embark on your own AI adventures.
Until next time, happy building.
Wow, it feels like we've covered so much ground in this deep dive into AWS AI. We've journeyed from the nuts and bolts of building AI with SageMaker to the ready-to-go power of those pre-built services.
Yeah, we even touched upon the almost magical realm of uh, generative AI and foundation models. Like AI is evolving from a powerful tool to a creative partner.
Exactly. And through it all, we've woven in those really crucial threads of responsible AI, that human element, and even practical things like security and cost. It's not just about the technology, it's how we use it wisely and effectively.
You've hit the nail on the head. This deep dive has really highlighted how AWS is making AI more accessible than ever before, really empowering developers, businesses, and even those without deep technical expertise to harness the power of AI.
I'm curious, from all the information we've explored, what are some of the key takeaways that stand out to you?
That Lego brick analogy really resonated with me. It perfectly captures how AWS provides these, modular building blocks for AI. You can choose the tools and services that best fit your needs and kind of assemble them to create those custom solutions.
I agree. That analogy really stuck with me too. It demystifies AI and makes it feel a lot more approachable, even for those who, might have felt intimidated by the complexity of it all.
Another key takeaway is the sheer breadth and depth of the AWS AI ecosystem. From the flexibility of SageMaker to the specialized power of those pre-built services, it's like there's a solution for almost every AI challenge imaginable.
And it's not just about having the tools, but also understanding the different approaches to AI, like the different types of machine learning and the nuances of feature engineering. It's about having a holistic view, really, of that AI landscape.
Exactly. And I think the discussions around responsible AI, the human-in-the-loop concept with MTurk, and the importance of ethical considerations, it really highlighted the human-centric aspect of AI. It's a powerful technology, but it needs to be guided by human values and used for the betterment of society.
Absolutely. It's a reminder that AI is not just about algorithms and data, it's about people. And we need to ensure it's being used to empower and benefit everyone.
I think this deep dive has equipped our listener with a really solid foundation for navigating the world of AWS AI.
I agree. From the technical aspects to those ethical considerations and the practical tips for managing AI workloads, they really have a roadmap for success in this exciting field.
But remember, this is just the beginning of their AI journey. There's always more to learn, explore, and create.
So to our listener, we really encourage you to continue exploring the resources and tools available from AWS. Dive deeper into those services that sparked your interest. Experiment with SageMaker. Don't hesitate to reach out to the AWS community for, guidance and support.
The world of AI is vast and ever-evolving, and the possibilities are truly limitless.
Thank you for joining us on this deep dive into AWS AI. We hope it sparked your curiosity and empowered you to embark on your own AI adventures.
Until next time, happy building.